Okay, today we are going to be solving radical equations. And the way I would present this to you is if you look at the equation on the left hand side of the screen, 2x plus 1 equals 5. And it's very similar to a radical equation, 2 times the square root of x plus 1 equals 5. In this example, we'd solve it by subtracting 1 from both sides of your equal sign. Those would cancel out. Bring down the 2x, and you solve this problem. 2x equals 4, and then solve for x by dividing both sides by 2. You do the same thing with this one over here on the right-hand side, in that we want to first isolate the radical. So everything underneath the square root sign, we want to get by itself on one side of the equal sign. So we'd use the same steps here. We'd subtract 1 from both sides, one from the left, and 1 from the right. They cancel out. And you have 2 times the square root of x equals 4. We divide both sides by 2. And you would get the square root of x equals 2. Now here's where this all differs. Whereas in a previous algebra problem, we might leave it like that. But we actually want to know what x is. In order to find what x is, we're going to raise both the left-hand side of the equal sign as well as the right-hand side to the second power. And what that basically does is it gets rid of or eliminates that square root. You're essentially multiplying the square root of x times the square root of x, and that would give you x. And you're also going to do that to the 2 here. So we're squaring 2, and that gives us x equals 4. Let's look at some additional examples. So in this problem, A, we're solving 2 times the square root of x plus 1 equals 4. We'd solve this problem just like you would solve 2x equals 4. And we would divide both sides by 2. Do the same thing here. So we'll divide this by 2 and divide the 4 by 2. And I'm just going to erase this because I don't want it to be confusing. And we're left with the square root of x plus 1 equals 2. All right, we want to get rid of the square root sign. So we're going to raise both sides of the equal sign to the second power. And that will eliminate this square root. So it just leaves us with x plus 1 equals 4. And we'd subtract 1 from both sides and have a solution of x equals 1. Over on this example, notice we have a cube root. We'll have to factor that in when we get to the step where we're eliminating the radical. But the first step, we would be adding 1 to both sides of the equal sign, because the first step in solving these problems is to isolate the radical, and that includes everything underneath the radical sign. So we have a cube root of 2x minus 9 equals 3. And then, whereas in this problem, we're taking the square root, we're basically squaring both sides. With these problems, we're taking the cube root, we'd be cubing both sides. We're raising both sides of the equal sign to the third power. There's our exponent of 3. Just like the square root problems, this radical is going to disappear, and we're left with 2x minus 9 equals 3 to the third power, or 27. And you just solve it like you would any two-step algebra problem. Add 9 to both sides. And the 9's would cancel. 2x equals 36. And divide both sides by 2. And your solution here would be x equals 18.